In today's tutorial, we're going to be looking at how to use cohesive elements. So I have two separate parts here, and you can see that they begin to separate as a load is applied. And that's because I have a cohesive layer that's separating the two parts, and that's allowed to split under certain loading conditions. So I'll just show you how to apply these elements now. We are going to start by I'm simply going to just remake these parts and start from scratch in a new model. Okay, so starting our new model, we need to first of all create our parts. So I'm just going to create a top part. This model that I will be creating today is a 2D model, but the method should apply also for a 3D model. Leave all the default values here. And I'm just going to be drawing fairly arbitrary dimensions here. Okay, so 5 is fine. I'll just make this a bit longer. And now just trimming off the lines I don't want. And adding a circle in the middle just so as I can apply my load in there. So actually there's another line here. Trim that off. Okay. So that'll be the top part. Now to make the bottom part. That'll be the same length. And accept that. So now we have those two parts. There are a couple of different ways that you can create a cohesive bond line between two structures, but the way that I'm going to be doing it is by creating a separate part, which is the cohesive elements. So just creating a new part, let's call it co for cohesive, and I will make this entire part from cohesive elements. So it's the same length as the others, but the height of it will be much smaller. So cohesive elements are significantly longer than they are tall. So I'm going to be using that dimension. So if I zoom in further again, you can see that it's very, very thin. So that's okay. We'll zoom out and accept that. And you can just see it there as a very faint line across my screen. The next thing then, okay, so we'll start creating the material properties. So the top and the bottom part, I will just make them out of steel, or you can call it whatever you want. I'm going to set the elastic properties, Young's modulus, and the Poisson's ratio. Okay, so that's the one of the materials. The second material then is for the cohesive. Okay. So create the elastic properties. We will want to put in traction there for the type. And I have stiffness values here. These are just example ones that I'm going to be using. Your own model, you'll need to figure out what is appropriate. Okay, it doesn't like to copy and paste in. Okay, so there's 9 zeros. Okay, the next thing that you'll have to apply is a traction separation law. The one I'm using in this example is the max S damage traction separation law. We will also apply, okay, we need to tell it how the damage is going to be evolving. In this example, I'm going to be using an energy type damage evolution, and my fracture energy in this example is that, okay, and back onto the damage criterion values. So here, just double checking them there, yeah. Okay, so I'm happy enough with that material. That's the cohesive material there. Now I have to create the sections. So for the steel section, we'll just call that steel. Okay, the material we'll use is the steel we created. Just going to switch on that. And now for the next section is the cohesive. So in category, well, first of all, we'll just type in the name, cohesive. In category, you have to select other and select cohesive there to create the correct kind of section. The material here is the cohesive material, and the response, it's a traction separation out of plane thickness. Just make it match what we did for the steel components. Okay, now back into the parts. When the cohesive elements have different material properties in different directions, so you have to set the material orientation. So make sure you're in the cohesive part, go down to orientations, and it's asking us to select the region to be assigned a local material orientation. So select the entire layer there, middle click, use the default coordinate system, and I use the second option here, element isoparametric direction 2. Okay, we will accept that. Okay, so we've assigned the orientation. Now just assign the sections. So again, select our whole part, middle click, and we're assigning the cohesive section to the cohesive part. And now into the top part, we don't need to give it an orientation here. We just select this region and say we're assigning the steel section type, and now again to the bottom part. So in section assignment, select the region, middle click, and it's steel for those two parts. Okay. And because I always forget to create the step, that's the next part I'm going to go to now. So create a new step. All the default values are fine. Incrementation. I have just gotten in the habit of adding a few more increments just to make sure that the model doesn't abort prematurely. And just increasing my minimum increment size, or sorry, decreasing it, making it smaller. And start off at a lower increment size as well. One more thing that I would like to do with the step, if we go back into it, so step 1 and edit, is switch on non-linear geometry. And we're just going to switch this on to be safe. You normally have it switched on when you have large deformations in your model, and the cohesive elements in this will be deforming significantly. So we can accept that. And now we can go and start assembling the model. So open up the assembly module, double click instances, and that's the bottom part. just switch on the auto offset and hit apply. Now the cohesive element, hit apply, and the top part and apply that. And just cancel out of that. So now the first thing we want to do is set up the tie constraints. So I'm going to tie the cohesive layer here to the top of this piece here. I'll do that first. We'll scroll down to constraints, and just particularly if you have many parts, it's useful if you just label these tie constraints in give it some kind of naming scheme that makes sense. So this is just cohesive to bottom, so the bottom part. So continue. So it says choose the master surface. I have found generally that the cohesive layer doesn't like being the master surface. Just for some reason I have difficulty running models like that. So I'm going to select this part here as the master surface, and now the slave surface will be the bottom surface on the cohesive layer. So I'll accept that, okay. And just accept the default values here, that's okay. Zoom out again. These boxes are slightly in the way here. Okay, and okay, so that's that one, so that's the top there tied to the bottom there. Now I want to do the same thing where I tie the top of the cohesive to the bottom of this part. So constraint, so this will be top to cohesive. So choose the master surface, again make this the master, and make the cohesive the slave surface. Zoom in, and it's the top surface this time, okay. Accept that. So now we've set up all our tie constraints. Before we can move these into position, I also want to set up contact constraints. So just, it probably won't be too much of a problem with this model because we're pulling this upwards off that, not pushing it onto it. But sometimes with bending moment and things like that, maybe the bottom end could end up being pushed down. So we don't want this part to intersect through this, so we have to set up surface to surface contact. So we'll do that now. Okay, in interaction, make sure you're into interaction module. And this is surface to surface contact, okay. Select the master surface, I'm just going to select this one here. And the slave surface, I'll select this one here. And we have to generate contact interaction properties. I'll just use very basic ones. So contact type, and I'm just going to switch on tangential behavior, which is frictionless in this example, and the normal behavior, I'll just use hard contact as the pressure over closure. Accept those two. And now we can start moving the parts into position. So go into the assembly module, and we will go to constraint coincident point, and it says select a point of the movable instance. So I'm going to move this cohesive layer to the right place first. So I'm going to click on this bottom left hand corner. Now it says select a point for the fixed instance. So I'll just zoom out, and that's this corner here. So if you zoom in, you should see now that the cohesive layer is lying on top of that part. Okay, we'll zoom out and now move this into position. So again, constraint coincident point, select the point for the movable instance, that's this here. And now select the point for the fixed instance, so now we're going to be moving it so that it's on top of the cohesive layer. There. So that's our object fully assembled, we are going to go and now apply the correct element types and mesh the objects. So double click mesh on the bottom part, seed part, okay, mesh, okay, element type, I'm just going to use a plane strain element. Okay, and now mesh part. So that's the bottom done. Now we have to, I'll just do the top first. So exact same thing here. Seed part 1. Obviously you'll get, this is a fairly rough mesh and it's quite messy in general, but I'm just using this for the sake of this example. So just checking the element type there. Yeah, okay, sorry, plane strain. Okay, so now into the cohesive element. Sorry, the cohesive part. So in mesh module, again, it's just that very thin line across there. So we have to change the mesh controls here. So we have to use a quad structured for these for this particular cohesive layer. Quad structured, okay. Now seed the part. I'm going to make this a bit finer than the other parts. Mesh part. Nope. Mesh, okay, so element type, select this region, and you have to, rather than selecting plane strain again here, there's a special cohesive family in the element types. So we'll select that. I'm just going to double check that that was done. Mesh element type. Yeah, and it's cohesive, so that's fine. And now we can mesh that part. Yeah. So we'll zoom in, just double check. Yeah, okay, so that's meshed correctly. One thing that I'm going to switch on from the field output requests is the status variable. So we'll just go into edit on the current field output 1 there, and if you scroll down to state, just tick the box there to open it up and click on the status variable there, and we'll accept that, and that means that the cohesive elements will start to disappear once they've failed. So you won't see them stretching as this thing is split apart, at least not beyond a certain limit. I think I'm ready to apply my very basic boundary conditions. For this example, I'm just going to make the base and cast ray, just lock it in position, and apply a displacement to this ring here. I don't know in real life how you would, maybe if you glued this to a bar and pulled on that to get every single edge to move, anyway, or every single surface in there. So I'm just going to be pulling it up a bit, pull it up 5 units. So that's up. That's the y direction. So that's U2, up 5 rather than -5, which would be down 5. Okay, so that's pulling up in that direction. Just trying to think if there's anything I've forgotten to do. Okay, we might be good now. So I'm just going to create the job. This will be job 3 for model 3 in this example. Parallelization, switching on as many processors as my laptop, sorry, as many cores as my laptop can use. Okay, and I think this is ready to run now. So we can see now that the model has successfully completed. So right click on that, go to my results. I'm just going to change, if you go to options and common and change the deformation scale factor, just make sure that it's set to 1. Apply that. And yeah, if we can click on the plot contours on the deformed shape, and yeah, okay, so that's the last increment there. So go back to the beginning and you can go step by step through the increments here. And you can see that, well, then the top part completely detaches from the bottom. But you can see as you continue from one step to the next, the elements are being deleted, the cohesive elements. This is because of the status variable that we enabled in the field outputs. So at a certain point, those elements are deleted once they've failed. And yeah, the whole thing has failed there. So that's the end of this tutorial, which shows you basically how to, at least in 2D, create a layer of cohesive elements and use the tie constraint to tie 2 parts to the cohesive layer. I hope you've enjoyed this, and I'll have a new video at some stage in the future. Thanks.